What is the first thing that comes to your mind when I say the word stream? A stream of water? Well, streams in Java are kind of similar in nature. In this chapter, we're going to talk about Java streams, intermediate operations, terminal operations, flat map, lazy evaluation, parallel streams, and a lot more. Coming next.
In this chapter, we're going to talk about Stream API. First of all, let me clarify that whenever I use the term stream in this chapter, I don't mean to say input stream or output stream. Stream in this chapter or in this context is different. We'll talk about it pretty soon. Consider the following example. Given a list of string elements, I need to perform these three tasks. Task number 1 is to store the list as an integer list, and task number 2, remove odd numbers from the list and store the even numbers in the list, and number 3, find the sum of all the remaining even numbers. Let me save your time by pausing this video, write the code, and get back. So here we have the code for each one of these tasks. In here, I'm just looping through all the elements in the list and converting each element into integer using the parseInt method of integer class, and I'm storing each one of these elements into a new list, which is an integer list. And in our second task, I've created a new list, and in here I'm just storing all the elements that are divisible by 2. And using this list, I'm trying to find the sum of all the elements present in that list, and I'm printing the output. Let's run the program, and you should see 30, which is expected. But definitely this is the worst way of writing the code because we're using for loop multiple times. We could use the for loop only once and get our task done. Let's see how we can do that. I'm going to get rid of the entire code in here. Do take note of all our tasks. I'm going to combine all these tasks together and write a shorter code. So for this, I'm going to use for each construct for string str in string list. So for each and every element in the list, I'm going to convert that into an integer, and for this I'm going to introduce a new variable, and let's call it value equals 0, and in here val equals integer dot parseInt str. This statement would convert the current element to integer, and we're going to have an if condition in here like int val mod of 2 equals 0. That means the number is divisible by 2. In that case, we assume that the number is an even number, and we're going to say sum equals sum plus the current element that is converted to integer. And guess what? That's all there is to it. Let's run the program and expect the same result. Awesome. Now let's see how we can accomplish the same set of tasks using streams. But before that, let us understand what is a stream with a wonderful example. Let's go to whiteboard. Let's say you have a reservoir with some water in it. Now your task is to purify this water from the reservoir and collect it into some container. And for this purpose, you're going to install a pipeline. Once you do so, the water will keep flowing in that pipeline. The water in here is nothing but a stream. We got stream of water in this pipeline. Now you want it to purify this water. Now you will pass this water into a section where it will remove the impurities from the water. Again, in the process, you would let the water flow into another section where you would kill the bacteria present in the water. And likewise, you would let the water flow into the final stage where you would add minerals into the water. And then you will finally collect the purified water into the container. So now we got a stream of water and it is going through multiple processes to ultimately get the result we wanted, to get the purified water. Stream in Java is no exception. Just like here, the water stream is having a source, which in this case is reservoir of water. Stream in Java is going to have a source. In our example, it's list of string elements. And just as the water is flowing through multiple processes, our stream in Java is going to go through multiple functions or methods in Java terms to get a final result. So instead of remove impurities, it's going to be a call to a method called map_to_int, which will convert the stream of string elements into a stream of integer elements. And instead of kill bacteria, it's going to be a call to a method called filter, which will eliminate some of the elements in the stream based on certain condition. In our example, in our task 2, we're going to eliminate all the elements that are not divisible by 2. And instead of add minerals, it's going to be method sum, which will find the sum of all the remaining elements. And finally, you would get the result. Let's see how we can accomplish this programmatically. Now, just as we created stream of water with reservoir as the source, we're going to create a stream of string elements with this list as the source. For that, I'm going to call the stream method of the list interface, which is going to be string list.stream. Now, as you would guess, this is going to be a default method. Let's store this stream into a stream object and is going to accept one generic parameter, which in this case is going to be string because we have a stream of string elements. Let's do import. Let's give it a name. Now let's move on to our first task. We're going to convert this stream into an integer stream. How do we do that? We're going to say str stream dot map_to_int is the method that you want to call. This is going to convert the string stream into an integer stream, but we need to tell how to do so. And for that purpose, this method is going to accept one functional interface as an argument. As you can see it's going to be toInt function. So let's make use of that. We can certainly make use of a lambda expression here. And the lambda expression says integer.parseInt and is going to take that element. And that's it. For each and every element, this will be executed, and ultimately our stream would constitute stream of integers. But we need to store this stream somewhere. It's going to be int stream. Let's import that. Now let's move on to next task, where we would remove all the integer elements that are not divisible by 2. For this, I'm going to say int stream dot filter. Now filter is going to accept one functional interface, which is going to be int predicate. Now this is the condition under which the filter method will decide whether to keep the element or to remove it. So let's make use of that. So for each element, we want to do the following. Now whatever the logic that you provide here has to return a Boolean value. E mod 2 equals 0. Then we want to keep that element. Again, this will return the int stream, which would now constitute only a limited set of elements because we have eliminated some of the elements based on this condition. Let's call it int stream 1. And finally, we're going to find the sum of all the leftover elements. For that, I'm going to call the method called sum. And with this, we're done with all our tasks. Let's run the program. The result is as expected. Now, just for the sake of your understanding, I have written code separately for each one of these individual tasks. But in fact, we can write all these in just one statement. So let me just do that for you. I'm going to copy this and have it in here, and then I'm going to copy this and then ignore the syntax errors. We'll get rid of them pretty soon. And I'm going to say dot sum. The resultant value is going to be int. And now we can get rid of everything in here, but just display this variable, the result. Let me just put these in individual lines. That will make the code look a lot cleaner. Let's save the file and run the program, and result is as expected. Now, what is the difference between these two examples? Again, this is more of a functional programming than our traditional Java program. In this example, we're not only focused on what needs to be done, but also how it needs to be done by using external iterators. Whereas in here, we're just focused on what needs to be done, and everything else is handled by these methods using internal iterators. Also, if you notice, in here we have clubbed or combined all our tasks in one go. This might look a little confusing, whereas in here we still retain the sequence of our tasks. So this looks ordered and more meaningful, or should I say more expressive and closer to human understandable language. Now, since you are used to writing Java programs using object-oriented programming approach, it might take a while to digest and start using streams. But I bet if you show these two programs to someone who never programmed before, he would understand streams better than this program. When we talk about parallel streams, you will also understand that there will be significant performance benefit as well with streams. So stay tuned. Alright, let's continue. In this example, we're kind of letting the stream of strings flow through all these methods down the line, and ultimately we're getting some kind of a result. In this case, it's the sum of all the integers left in the stream. Well, this instruction is actually a combination of three different operations. Number one is to create the stream. In this case, we're creating the stream from the list, but there are many different ways you can create the stream. We're going to talk about it in a minute. And then the second operation is the intermediate operations. In this case, we have a couple of them: map to int and filter. The job of intermediate operations would typically be take the stream, make changes to it, and then return back the modified stream so that you can further apply some more intermediate operations on the modified stream. And finally, we have a terminal operation, and this would be only one. The terminal operation will not return a stream, it will return some kind of a result. And once you call a terminal operation, you cannot further work on the same stream. Now, what we're going to talk about in this video is different ways to create a stream, different types of intermediate operations, and different types of terminal operations we have. First, let's talk about different ways you can create a stream. Let me run this program so that we can simultaneously look at the results of this program. Let's expand this or collapse. Now, for the sake of better visibility, I have closed all the extra panels which we're not requiring at the moment. So in here, we're creating a stream from the list just as we did in here. We have a list, and I'm using the method stream to create a stream out of this list. Print stream is a method which I have just written to print whatever is there in the current stream. I'm going to use this method everywhere to show the result on the console. Now, you don't have to go look at what's happening inside this method. We're going to talk about it later point of time. But just in case if you're curious, we're just using this method for each, which will let us loop through all the elements in the stream and do something with it. And in here, I'm just using a sysout statement to print each one of those elements and appending a new line character after that so that the output looks formatted. You can also create a stream from an array. We have a character array, and I'm just going to pass that array to stream.off is the method name, and it's going to accept this argument, the array, and is going to return a character stream, and I'm just printing that, and that's exactly what you're seeing in here, stream from array. If you wanted to create a stream out of a subset of an array, you're going to use the method stream of the arrays class, and you would give 3 parameters. The first one is the array itself, start index and ending index. Now whatever you give in here is not inclusive, which means if I give 1 and 3, it's going to be index 1, index 2, and that's it. It's not going to take into account index 3. So we're going to see P and P, and that's exactly what we have in here. You can also generate infinite stream by using generate and iterate methods of stream. In this case, I'm trying to generate random integers. I'm making use of the class random, and then I'm calling the nextInt method. This would generate a random integer. And whenever you use the method generate, it's going to create an infinite stream. So we need to use some kind of a termination operation like limit with some parameter to tell how many random integers do we want to generate. In this case, it's going to be 3, and that's what we specified in here. Similarly, the iterate method is going to generate infinite stream, and that's why we need to use a limiting operation like limit. The way the iterate method works is it's going to generate an infinite stream with 10 as the first element of the stream. The second element is generated by applying the function, in this case it's x plus 1, on the first element, so we get 11. And the third element is generated by applying the function x plus 1 on the second element. Likewise, it keeps on generating infinite stream. But since we limited it to be of size 3, in this case it's going to generate only 3 elements. You can also build a stream on the fly like this by using the add method. This methodology is not used very often. You can also create a stream from a string by using the chars method of the string class. And in here, I'm just trying to print them on the console. So for lowercase a, it's going to be 97. For p, it's going to be 112. Likewise, we got rest of the elements in the stream. You can also use the method range to create a stream of integers. If you're going to call the range method of int stream, then this is going to create an int stream from 3 to 9. So it's 3 to 9. And do take a note that it's going to ignore 10. But if you want to include it, then you need to call this method range closed. That would also include whatever you provide in here. So for closed range, we got 3 to 10. Similarly, if you call the range method of long stream, it's going to generate a stream that constitutes elements of long type from 3 to 9. Now you may have a question on your mind. What's the difference between int stream and stream of integer? Well, stream of integer is a stream of integers, which means I'm talking about the object integer, but whereas int stream is actually a stream of primitive int. Similarly in here, it's a stream of primitive data type long. Hope that's clear. In the next video, we're going to talk about some of the intermediate operations. Stay tuned. Alright, let's continue. In this video, we're going to talk about intermediate operations. I already have this program run, and for your convenience, I'm going to get rid of this panel. You can get it back whenever you want. So in here, I have a couple of lists. One is of integer, the other is of string. I'm using the method filter to filter out some of the elements from the integer stream based on this condition. So basically the filter method will eliminate all the elements that are not greater than 5. So the resultant stream is going to constitute all these values which are greater than 5. Map, on the other hand, is similar to filter, except it's not going to eliminate any elements from the stream. It would just simply apply this function on each and every element. So here is the output of map. The function is applied on all the elements. You can use the methods map to int, map to long, and map to double to convert the stream into a primitive type stream. In this case, we're converting our stream of strings, which is this, to primitive int stream. Same is the case with these two instructions, long stream and double stream. You can also sort the stream in a particular order. If it's an integer stream, by default it's going to be sorted as ascending order. So we got the stream sorted in here. If you want to sort the stream in reverse order, then you're going to pass in the comparator like so, and we got the stream sorted in reverse order. Also, you can sort your own custom objects by creating your own comparator. We've already taken a look at such example in collections chapter. The skip method will let us skip some n number of elements at the start of the stream. So we got rest of the elements. And finally we have the limit method. We in fact had already talked about it in this example. It's the exact same thing we have in here. So this should summarize on intermediate operations. Also note that the limit method is also called as a short circuit operation because it will return a finite stream from an infinite stream. Without this method, the stream keeps on getting random integer numbers. So we always use some kind of a method like this. So these are pretty much the intermediate operations. See you in my next video. Alright, in this video we're going to talk about terminal operations. Terminal operations, as the name suggests, they come at the end of the statement and they will return a result instead of a stream. Which also means that once if you use a terminal operation, you can no longer work on that stream. Let's take a look at some of the terminal operations or methods we have in the Stream API. The first method that we're going to take a look at is the count. It will help you get the number of elements in the stream, an example of which you can see it over here. Let's run the program. So we got a couple of streams and their counts. We also got a method collect, and it will help you convert the stream to a collection. In this case, I have converted it to an integer list. So you're going to call this method collect, and you will have this as an argument. The for each method is used to iterate on each and every element in the stream and apply the specified function. This may sound similar to our map method, but this is not going to return a stream. This will just simply apply this function on each and every element, and that's what we have in here. The reduce method is a little tricky, and for the convenience of explanation, I'm also doing a sysout of the parameters being passed to this lambda expression. So here's how reduce method works. It's going to take in the first two parameters in the stream, it's 2 and 7, and is going to perform this function on those two parameters. And again, it's going to call itself by sending the result of this as the first argument and the next element present in the stream, which will be 4, as the second argument. And that's why we got 7 plus 2, 9. So 9 is again passed to the same method with the next element in the stream. Again, it's going to find the sum of these two, which will be 13, will be passed to the same method again, along with the next element, which will be 1, if you take a look at it. Same thing keeps going until we get a final result, which will be 55. I hope it's clear. We also have short circuit terminal operations, as these methods can return something even from infinite stream, an example of which can be seen in here. The method anyMatch is going to return a Boolean value, and it would basically check to see if there is any element in the stream that match the specified condition. In this case, our stream is random generation of integers, so this will be an infinite stream, but this method is going to stop the stream once it comes across with an element that will meet this condition, basically a numerical that is divisible by 5, and that's why we got true as a result. Similarly, from the integer stream, I'm trying to see if there is any element that matches this condition, and again it's true. And even in here, I'm checking to see if there is banana present in the string stream, and in fact it is, so it's true. Similarly, we also got all match method, and it would check to see if all the elements in the stream meet the following condition. If there is at least one element that doesn't meet the condition, then it's going to return false. So not all elements in the integer stream we had are divisible by 5, and so it returned false. And we're checking if all of our stream elements are less than 50. They are, so we got true. None match will actually check to see if none of the elements in the stream match the specified condition. We got the results in here. The find first method will return the first element that will meet the specified condition, and find any, as you can guess, it will find and return any element that meets the condition. So we got those elements printed in here. Also, there are a couple of more methods which are a little tricky. We're going to talk about them in coming videos. See you in my next video. Alright, in this video we're going to talk about flat map. Sometimes you might want to combine multiple streams into one stream, and that's when you would use flat map. The best way to explain it is with an example. In this program, I've created 4 different integer lists and I've added them in here. So this statement in here is going to create a stream of elements, and each element in this case is individual list. And I'm using the map method to perform certain operation on each one of those elements and generate another stream. In this case, I'm just trying to get stream from each and every individual element, and since each element is of type list, this will work. Ultimately, we get another stream that constitute list of elements, and each element is of type stream. So in essence, until this point, we're actually getting a stream of streams. Hope it's not confusing. And I'm using the for each method to loop through each and every individual stream element, and I'm doing sysout. Let's see how the output looks. We're going to get list of objects which are of type stream. Now let's see how the result would look if I use flat map. Now the flat map is going to combine all the individual streams, and the resultant stream would constitute list of elements, which are these integer numbers. Let's try to run the program. There it is. So what's the difference between a map and a flat map? Map is going to apply this function on each and every individual element in the stream and generate another stream with updated elements. But whereas flat map, it not only applies this function on each and every individual element in the stream, but would also flatten them or combine them into a single stream. So whenever you have a stream of streams, you can use flat map. If this sounds confusing, let's take a look at another example. Let's comment this line out and let's uncomment this. In here, with this instruction, when I do files.lines, this would actually create a stream of strings. In this case, each string is each and every individual line in the specified file. Do take a note of the syntax in here. And then I'm going to use the map method to perform certain operation on each and every element, which in this case is a string. And the thing that I'm doing here is on each and every line, I'm going to split using a white space character. This would give me a string array, and I'm converting that array into a list using arrays.asList, and I'm doing .stream to generate a stream of that list. Now so far in this instruction, we are again creating a stream of streams, and for each and every element, with each element a stream itself, I'm doing sysout. Do take a note that I'm using a method reference. This is equivalent to this. Let's run the program. Now let's try using flat map, so that would sort of combine all the streams into a single stream. Now let's run the program. You would see each and every individual element, which would be now a word, would be listed like this. Now this is all is a single stream. If this still sounds confusing, then you can just simply ignore. We rarely come across with using a flat map, honestly. So see you in my next video. Okay, in this example we're going to talk about something called lazy evaluation, which means you don't want to perform intermediate operations unless there is a real need for it. In this example, we're performing filter and map operations, but we're not doing anything with the resultant stream. So why should the Java virtual machine perform filter and map operations on this stream? That's unnecessary performance overhead, right? So we need to perform some kind of a terminal operation. Only then will the filter and map operations be applied on this stream. For example, we can do count, or let me just prove my point by running this program. What is the output that you're expecting? Obviously nothing, because we don't have a system.out.println method, or we're not converting this stream into a list and then printing it, anything of that sort. For the purpose of debugging, we can make use of a method called peek. Let me just show you what it is. I'll do peek. I'm going to pass in the element, and I'm going to do something in here. In this case, it's system.out.println, and then I'm just simply going to print that element. So the peek method will actually help us execute a set of instructions on the current element that is in the stream, so that it will help you in debugging. You'll see the peek method in action in a while. Let's put some kind of a meaningful description in here. filtered element. I'm going to copy the same instruction after the map as well, like so. Mapped element. Now as the stream goes down the line, the peak method will print the element. Now if you run the program, it's not going to print anything. That's because the filter and map functions are not applied on the stream yet. Because guess what? We don't have a terminal operation. Let's perform some kind of a terminal operation, something like a count. Now if you run the program, you would see the output from these peak methods. This is called lazy evaluation, which means the intermediate operations are going to be lazy and they don't perform any kind of operations on the streams unless there is a call to do so. A call in here is nothing but a terminal operation. Well, actually I should also mention that while the stream is going down the line, I don't mean to say that filter will be performed first and the list of filtered elements will then be fed into the map method and then it will be passed on to the count method to count the number of elements. That's not going to be the case. Although the stream is going down the line, the method call will actually go from bottom to top. The count method will actually request the map method to get the elements to be counted, and the map method will in turn request for elements which will start with letter B. The filter method will find the first element and is going to return it back to the map method. The map method will apply this function on that element and forward it to the count method. Since the stream hasn't ended yet, the count method is again going to do the same, requesting for more elements, and the call goes back to the filter method. The filter method will again comes across with this element which satisfies this condition, which is also the last element present in the stream. So the element is returned back to the map method. The map will return to the count method. Ultimately we get the amount of elements that are left in the stream. Hope that's clear. One of the other reasons why intermediate operations has to be lazy can be explained with the code in here. Let's just uncomment that by commenting this out. So in here we're trying to generate an infinite stream using the iterate method. If the stream is not lazy, then this instruction should keep on creating the stream forever without ever reaching. Luckily stream is lazy, so this program doesn't go forever. Of course nothing will get printed. We can use the for each method to print the element. Let's run the program. There it is. Alright, that's it on lazy evaluation. But wait, maybe I just want to quickly point out that you cannot reuse a stream. Streams are meant to be used only once. In this case, we got an integer stream and we have used it once already. We cannot use the same stream again to try to get the elements. For example, let's say count. This is going to give an exception. And that makes sense because if you remember in our example where we're taking the water from the reservoir, once we take out all the water present in the reservoir and purify them, we got the result, the purified water, but there is no water left in the reservoir to take, so we cannot reuse it. It's only for one-time purpose. Alright, that's it on this video. See you in my next video. In this video we're going to talk about something called a parallel stream. Parallel stream will divide the stream into multiple substreams, also known as forking, and they all run as individual threads on individual CPU cores, and finally all the results of individual substreams are clubbed together into a single result, also called as joining. So it's a fork and join mechanism which was already in place in Java. To make this stream a parallel stream, you don't have to make a huge number of changes. All you have to do is use parallel stream instead of stream, and everything will be taken care internally. You don't have to explicitly create multiple threads, divide the stream into multiple substreams, etc. There's no such mess. Everything will be handled internally just by calling this method parallel stream. Obviously, when you have a single stream split up and run as multiple threads, it's going to increase the performance, just as multi-threaded programming. Does that mean that we should always use parallel stream instead of a stream? The answer is no. In some cases, parallel stream are best, and in some cases, parallel streams are the worst. Because, as I've mentioned, parallel stream would split the stream into multiple threads, with each thread handling individual substream. And as we know, that creating a thread and maintaining it would require some CPU and memory resources. So what do I mean to say by that is, in case if you're performing less CPU demanding operations, like in this case, you're just trying to filter out the even numbers and find the sum. This is very simple operation and it does not really require too much of CPU. In this case, you would better off go with stream instead of parallel stream. On the other hand, if you do any CPU intensive operations that would take a while to run, in that case, you better go with parallel streams. You need to make your choice wisely. For the sake of your reference, I'm going to leave this to be a parallel stream, but ideally in this scenario, the better choice would be to use a stream. Let's run the program and see the output. There it is. Alright, that's it on this video. Thanks for watching. In this video, we're going to take a look at some of the improvements that were brought in Stream API in Java version 9. So to demonstrate it, I'm going to actually create an integer stream. We're going to iterate through them. I'm going to start with the value 1 and would like to increment the value by 1. The first method that I would like to demonstrate is so-called take while. This method would allow me to enter a predicate and will keep on accepting the elements till the point this condition is satisfied. Once this condition is failed, then we'll stop accepting the new elements. Going to say x is less than 10, and let's print the elements. For each system.out println. Save the file and let's launch our application. So the values are printed until 9. In short, we'll take the elements while this condition is met. The opposite of this is drop while. We'll drop the elements till the point this condition is met. So we're not going to see all these elements, but we'll see the rest of the elements. The problem here is this would just go on forever. We're just going to drop the elements until 9 and we keep on printing the rest of the integers. Let me just run the program and show you what I mean. So this is going to go on till the time we hit the max value. I'm going to explicitly stop this. So what Java 9 allows us to do is we can now have a predicate. If you go to the description of the iterate method, we now have a couple of variants of this method. One is with 2 parameters, which we have just used, and the other with 3 parameters. So we have this has next. a predicate. We can put the condition, for instance, that says I is less than 50 or whatever. Save the file and let's now launch our application once again. And it's just going to print the values until 50, but if you notice, it shouldn't print the initial 9 values. That's because for those values we have this condition becoming true.
I hope you enjoyed this tutorial. Please like and subscribe. The link to the next part of this course is in the description below. Also, if you want to learn Java with practice, with quizzes, assignments, coding puzzles, and interview questions, I cannot do that on YouTube. So you need to take this course on my own website. The link is in the description below. I'll see you in the next part of this course.